The violin falls under the category of stringed instruments, and each string, there's a note on either side of every string, meaning that the length of the string is equal to 1/2 of the total wavelength. So starting off with how we even hear the violin. So when a string of a violin is either plucked or bowed, the sound waves generated that resonate with the fundamental frequency of the string are going to be the ones that persist, and this leads to the generation of sound waves in the air at the same frequency. So that's how we hear it. There are 4 different strings on a violin. There's a G string, a D string, an A string, and an E string. These are all different frequencies. G is the lowest, and it happens to be the thickest. So when it comes to linear mass density, that is inversely proportional to frequency. And so since it has the highest linear mass density, it is the lowest sounding string, because pitch is also proportional to frequency, meaning that the G string also generates sound waves of the longest wavelength. When we press down on any of the violin strings, it's going to be shortening that length, meaning it decreases the wavelength because the length of the string is proportional to its wavelength, and this leads to an increase in frequency. Finally, when we are tuning a violin, you would want to pull the pegs. You can either move them one way or the other. When you tighten the string, you're going to be increasing its tension, and this increases frequency. And when you loosen the string, you're going to be decreasing tension and thus decreasing the frequency. So you can change how loud you play based on how much you are pressing on the bow that is going across the string. So the harder you press on the bow, the louder the violin will sound. And the lighter you press on the bow, the quieter the violin will sound. And similarly, if you pluck your finger very lightly, you'll get a quiet sound. And if you really pluck it hard, you'll get a louder sound.